so let's get into study unit 10. So your assignment 5 will be on study unit 10 and 11. And again, in the exam, your exam paper will consist about 2 of these questions. In your your extra study guide that you have with examples and those kind of things, there is a mistake in there in the formula. So when you, and I will highlight it here in my slides as well. So when you just look at that, there is a mistake in that extra book. So in your normal study guide, where the work is being explained, that is correct, but in your extra question guide, there is a mistake in the summary with the formula of the study unit on how to calculate the chi-square. And there's different names of how people pronounce it. I like to call it chi-square, but there's other names as well. So when we look at study unit 10, there is, and I should have brought it into this. There is and I'll send it to you in any case. In your study guide, there's this nice block. So let me actually open it up. Let's just quickly show it for you. I'll even copy it in. That nearly summarizes very nicely what you need to know about this study unit. So study unit 10, where was it here? So this is basically a nice summary of what you need to know for the exam. Okay, so because this, and we'll quickly go through a few of it before we get to the others. But so basically, the 2 things that we will always ask is if something is independent or not. So you will always get in your questions nearly that option of independence or not independent. The other thing that is important is to calculate the degrees of freedom, or they give it to you, or you need it to make a decision or to get your chi-square value from a table. So either or, but so that is important. Then for us to work out an expected value. So they will normally give you in the table the observed value. They can ask you to work out the expected value, and they can ask you to work out the test statistic. This, and let's be honest, this happens not a lot, that you need to work this out. It might be in your assignment that they ask you to do this. If they ask you to work this out, they will give you the observed values, let me put it that way, and they will give you the expected values. Um, and then you can make that calculation of observed minus expected. Um, but this happens seldom. If something like this happens, it will be on a 2 by 2 table or something like that. But then they will normally give you the two tables because it is such more time consuming. So if you get it in the assignment, um, this is nearly what you need to do, but it happens not a lot that it will be in your exam because it takes time. So for me, again, that was nearly the summary. So important, your H0 is always independent. Always, always, always. So it is like we have in our hypothesis of the norm and or the mean and things like that. We always say your mean is equal to. So in your chi-square, we always saying your null hypothesis are independent. And that is very important because you'll see sometimes that they throw those two around and then you actually know that that is the incorrect answer. Okay, how to work out the degrees of freedom? So let's have this table and let's have it a 2 by 1 table or 2 by 3. So let's say that's row 1, that's row 2, column 1, column 2, column 3. So what it tells us is how many rows are there? There's 2 rows. So 2 minus 1 for that kind of formula. How many columns? 3 columns, so 3 minus 1. So 2 minus 1 is 1. 3 minus 1 is 2. The answer will be 2. So just we'll get through a few examples of that as well. Just remember this. The place where they going to catch you out is if they add a total. So remember this is around the variables. So how many variables? There's still 2 variables. So total is never part of the equation to work out the degrees of freedom. I think that is very important because a lot of time they include total and we quickly say, oh no, there's 3, there's 4, and then we do get the wrong answer. So total is never part of your equation to work out the degrees of freedom. Okay, so here is, if, sorry, if you hear barking in the background, there is a fun run happening through the neighborhood and the dog is barking at everyone. So just sorry about that. So in your, and I think let me also open that up so that you guys can just see that in this extra textbook thingy that you have, there you can see what the test statistic that they have included in their summary. And that is wrong. And so unfortunately, I don't have real marker to mark that as wrong. So that is on page 210 in your extra study guide. So on page 210 on that extra study guide, so that is wrong. Your equation should be my observed value minus the expected value, the square root or the square of that divided by the expected. Here, they made all of that as one calculation and then only the squares, and that makes a huge difference in your answer. Okay, so very important just in that extra study book, how they calculate the expected value is wrong. Okay. Or the chi-square value, it is wrong. And then, like the normal distribution, we are going to make a rule about when do we accept and when do we reject the null hypothesis. So again, here you can see when the t-stat, and that is nearly just like we had in previous chapter 9 on hypothesis testing, when a t-stat is greater than the critical value, that one we can merely take through, we will reject the null hypothesis. So now we can play around with that wording to say, well, if a t-stat is smaller than the critical value, we accept the null hypothesis. Okay, so that for me is a very important one when we start to make the assumptions and go through the rules and answering the questions. Okay, so let's get into this. Sometimes they give you easier questions in the exam. Sometimes they give you more difficult questions. What I've seen, and it's not to make you worried or anything like that, is that the first paper sometimes might feel more difficult because it is the easier work of a course, and sometimes they try to catch you out there. Where in the second paper, it's sometimes easier questions, but because you're doing it now after that first paper that you nearly got a fright of, you sometimes just like totally have a mental block on it. So just be aware of it, that it might be that because it's going to be 2 sessions, you write an hour and 15 minutes for the one session, an hour and 50 minutes for the second session. So you can, between the sessions, just take a breather, go and make a coffee nearly, and then get back into the second session. So okay, so let's continue. If a continuing table have 4 rows, so let's just do that. 4 rows and 5 columns. How many degrees? So we know the formula is row minus 1, column minus 1. So this is a nice one. 4 minus 1, 5 minus 1. So that is 3 times 4, and the answer is 12. It will be awesome if you get something like this. but yeah, just so when you get these things that also seems too easy to be true, um, there are those questions in as well. Um, and it is also to nearly make you wonder if you're missing something. Yes, there's a hand. I think it's Simon. You can ask.
Okay, morning, Ian. Yeah, I was just a bit confused there because I thought that in the first brackets, I thought is the a square root, so I realized that is an R for the rows, and the next one is C for the columns. Okay, thank you.
Okay, yeah. So this is straight from that degrees of freedom formula.
Okay, thank you, Ian.
Cool. Okay, so you will also see in everything that is in the questions, it will nearly cover these these 4 or 5 things because there's nothing else around it that they can ask. The last one that they just can ask is accept or reject one. Okay, but else this is what we need to know. Okay, cool. Okay, so now let's get into the real life of this. Um, which one is incorrect? So let me do that. Okay, so which one is incorrect? Okay, so let's start at the top. We said we're gonna look at. Let me wanna just make it very small. But there it is. Okay, so we have that as just reference every time. So let's first look at null hypothesis, alternative hypothesis. Okay, null hypothesis H0 is the two variables are independent. Correct. Okay, so unfortunately, um, we're nowhere yet, so we need to go on. Alternative hypothesis is dependent. Correct. Okay, so there was nearly the first one. Degrees of freedom. No, we're not needed to do degrees of freedom in this one, but that would have been second one that I would have tested. Well, we need degrees of freedom to get to a critical value, so let's work out degrees of freedom. How many rows, how many columns? So how many columns? 1, 2. Remember, we don't take total into account because it's not a variable. How many rows? 1, 2. Again, we don't take total into account. Okay, so 2 minus 1, 2 minus 1 is 1 times 1. So your degrees of freedom is going to be 1. So when we go to another table, obviously they bombard you with tables in, but so when we go to um, chi-square that we're doing, there is a chi-square table. It is on page 200 in your study guide. So page 200 in your study guide, there is the chi-square table. Okay, but we will get there now. Okay, so degrees of freedom 1. The professor wants us to test it against 5%. Okay, so let's look at that table. Okay, so 5%. Let's go at the top, 5%. Now we just need to remember what 5% is in, it's 0.05. So we're looking at that area that we're testing. It's 5%, so 0.05. 0.05. Sure, it's way too early. Was that wrong? Let me just check why am I wrong. The degrees of freedom is 1. I looked at the wrong one. So here is, just makes easier to make. Let me see if I can get a different color. Doesn't seem like it. Okay, so degrees of freedom 1. Need to get DOV stuff. Degrees freedom 1. Ratio 0.05. So where the two meet, we've got 3.841. 3.841. Okay, so that one is also right. Okay, so we used the table. Now they're throwing in that we need to work out an expected frequency. So the frequency for yes and for B. So they basically want us to work out what is that expected frequency going to be. Okay, 25 is the observed frequency. Okay, so 25 as in there is the observed frequency and not expected. But we still need to work out the expected, because the expected can also be 25. By fluke, it can be the same. So let's just make sure. But that 25, we call the observed value. But let's work it out. So to work out that expected frequency, it is the row total. So the yes total, which is 65, times the column total. So the column total was B, which was 70. And we'll divide that by the total, which was 145. And so for this, nearly somewhere, my calculator has disappeared. So let's go to cell phone. 65 times 70 divided by 145. I get something like 31.4. You guys can just check, but then we know that one is incorrect. Okay, but let's also work out the critical, or not going to work out, they tell us what the T-stat was. And remember, if T-stat is bigger than critical, we reject. So let's write that down. If T-stat is bigger than critical, we reject. Sure, I'm writing like a doctor today. So let's see. T-stat is 4.5455. That is bigger than your critical value, which is 3,841. So because of that, we can reject. So suppose we calculated T-stat was that, the null hypothesis is rejected, which is correct. Okay, so in this one question, they tested that. They actually tested that because you needed it for the critical value. They tested the expected value. They did not ask you to work that out, but they asked you to use that in using the table to make a decision about reject or not. Okay, so this is nearly in most of your instances for the chi-square that this will be the way that we will go through it. Yes, there's a question.
Hi, John. Thanks. Just a quick one.
Yes.
Hi, just to confirm. So if you look at the row total of that 65, that includes the A value. So it's 40 plus 25, 65. And the column total will only be the B values.
Yes.
Okay.
Yes.
Cool.
Yeah. So nearly think of it back when we did way early in the year when we did probabilities. So basically, again, unfortunately, it is online, but what I would have just done is I just would have highlighted that. And then you know you're working with a 65 and you're working with a 70. Unfortunately, with the online, it's not as easy to do that anymore.
Thank you.
Cool. Simon, do you have a question?
No.
Okay, cool. Okay, so let's go to the next one. And you can see I'll in most instances I would, and that's why for you guys when you write the exam as well, it's nearly have all of these things together that you can nearly see, okay, but what I need to know about chi-square, look at the page, okay, it must be one of these things. Your exam has a flow. So it is, the first session is chapters 1 to 5. The second session is chapters 6 to 11. So it has a flow. It doesn't jump around between. So when you get to your last 4 or 5 questions, you know it's going to be chi-square and you know it's going to be on a regression. So, but nearly I would, for each chapter, like I'll send my screenshots again for you, but nearly for each chapter have the important things together that you know the first two questions is chapter 1. 3 and 4 will be normally chapter 2. There's one chapter, I think chapter 5, that there might be three questions in or something like that. Okay, so let's follow the same principle here as well. Let's first look at H0 and H1. So H0 is values are independent, correct. H1 values are dependent. Okay, cool. Okay, so those two are sorted. We're still looking for incorrect. Then your third one. So let's check. Done that. Degrees of freedom. In a test of independence of two variables, one of the variables has two possible categories, and the other has three possible categories. Okay, so you're looking at there's two possible categories, and in the other one there is three possible categories. Okay. It doesn't matter which one is a row, which one is column. In the end, we'll just multiply it. So let's say 2 minus 1, 3 minus 1. So that is 2 minus 1 is 1, 3 minus 1 is 2. So your answer is 2. So your degrees of freedom 1 is the incorrect one. Okay, so that's why for me also that is my steps that I will always follow, because that's the easier ones. When we now need to start working out expected values and critical values and it does become a bit, don't want to say more difficult, but it takes time. And time is very limited in the exams. But now we have time. So let me critical value we basically get from the table. So let's see, what do they tell us. Suppose that you calculate the t-stat. So we'll use the t-stat later. So remember, if the t-stat is bigger than critical, we reject H0. So let's just as a reminder again. Okay, 5% level. So now we know 5%, but degrees of freedom is 2. Okay, 5% still, degrees of freedom 2. So now we're sitting with 5.991. 5.991 is correct. Okay, so your critical value, 5.991. The value that you calculated, and luckily they give that to you, is 3.456. So your t-stat is not bigger than your critical value. So when it is not bigger, we accept the null hypothesis. And so let's see what other words they use. Fail to reject means accept. Okay, so that is also, so just again some different wordings, but fail to reject, so you can, and that is correct as well. Okay, so again, here now they didn't ask expected, but they ask that we use that and that. Okay, so for me, chi-square is again, it follows a pattern that you just need to do. There is one that we need to do both. So let's see if we still have time. Just really want to add all of these things that okay. Okay, so let's look now at this one. And here now you see that what they also like is to give you incompleted tables. So in this instance, before we go through this whole exercise of getting all the numbers, let's just follow still our principle that we've done. H0, H1. So let's look at that principle of, so H0, the two are dependent. Okay, so you're looking for correct. Okay, H0, the two are dependent. H0, independence. Okay, wrong. I now nearly wanted to say, oh, this was a quick one. So again, it's it is unfortunate that it that's not how it, again, for me, is how I need to catch you out with asking if something is correct, and then suddenly the next question I ask you if it is incorrect, because that just again, I feel it's a bit, but that's not my my decision. So, but in the exam, I will probably have gotten this wrong, because I would have said, I would have gone for a short route and said that is wrong, without even reading. Okay, so let's look at, so we've done, there's not another dependence, independence. Let's look at degrees of freedom. So degrees of freedom, how many rows? 1, 2. Remember, we don't take in total, because total is not a variable. How many columns of variables? 1, 2. Okay, so 2 minus 1 is 1. 2 minus 1 is 1. So 1 times 1 is 1. So let's look at anywhere a degrees of freedom. The degree of freedom, 1, correct. Okay, so in the exam, that now showed me again, before you nearly tackle it from above to say, okay, let's now work out observe, let's now work out that. Yeah, very easily your degrees of freedom was the incorrect one. Okay, so just a hint nearly again, if follow the process that gives you the least of work to do, because that will also nearly give you the least, your, or will optimize the time that you that you can work on other stuff. Okay, so let's then still do the others. I think it is very important to look at the others. So observed frequency. Observed is as is in the table. So let's look at the observed for acceptable. And again, unfortunately, you guys can online do this, but for acceptable and for John. Okay, so unfortunately now we don't know what it is. We have a total of that row, 950. We have what acceptable is. So 950 minus 265 is 685. So again, that is wrong because that should be 685. Okay. And remember, that is observed. So observed is, if I ask us what is the observed frequency for acceptable and Peter, it would have been the 265. So observed is as is in the table. Okay, then now we need to work out expected frequency. Expected is row total times your column total divided by n. So let's see, they ask us for acceptable, so that is 950. They ask us for the employee is Peter. So now we need to get that total. That total is just 100 minus the 700 will give you the 300. So let's just so that was 685. Let's just complete this now. Even if it's not needed for everything, 1000 minus the 950 would have given us 50. 700 minus 685 would have given us 15. 50 minus 15 would have given us 35. 35 plus 265 would have given us the 300. So 3 plus the 700 will give you 1000. So, and then we divide that by 1000. So we are using that rule now in this instance. So total of acceptance is 950. The total of repeaters of 300. And if you divide that by 1000, we get equal to 285. So here you could see the value that they've given us is actually the observed value and not the expected value. So the expected value should be 285. Okay, so then let's see. T-stat bigger than critical reject. T-stat, if I give that to us, T-stat bigger than critical, we reject. Suppose the calculated T-stat is 40. and let's test at 5% level. Okay, so let's see what the critical value was. They didn't ask us, they didn't give us, but we know degrees of freedom is 1. Critical, the alpha is 0.5. 1, so again, we work with a 3.841. 3.841. So your T stat is bigger than critical, and we reject a 0, sorry for the spelling there. So is not rejected, is wrong. That's why that one is also wrong. Okay, so again, in this one question, we needed to do that, we needed to do that, we needed to do that. The T stat we will do in the next one nearly, but I think I'll keep that as one for last or for you to do. And then we also used the table to get to our critical value. Okay, so this might happen. Okay, in the exam, this will be in your assignment, because that is just they want you to do these kind of things. So where was okay, so let's in any case needed to copy that over. So let's do it. We can always next week finish finish this chapter. We don't need to finish it today. This one is very simple to rather use it in Excel. So after we've now done all of these things, I'll just show you in Excel or one of our catch-up sessions. I'll nearly do all of from study unit 1 to 11 what can be done in Excel. I'll show you that again, but check in the Excel that I have shared. I will share that again in the today or during the week that you can use it. Because what we now need to do is we need to say, okay, we need to calculate that. So the formula there is you take your observed value, you minus your expected value, and it's very similar to when we needed to work out standard deviation and variation, and those things, and then you divide it by the expected. Then you need to do the same for the next one. So I'll give you the how to do it. Then you need it for the next one, 10. So let's just do that. 10 minus 12.49. us. The last one, I think that was now 36 minus. And that will give you an answer of, did I actually, okay, so here it is, actually gives you the answer of 1.5766. What I've done, and this is also out of your, because they used the wrong formula, that is wrong, but your answer is still correct. So when you look at some of these in the extra, so let's look at that first one was 0, what was it, 0.6520. So let's work that quickly out. So 12 minus 9.51, that is 2.49. At 2.49 times 2.49 is around 6.2. You divide that by 9.51, you get that answer. Okay, so in your guide, that extra study guide with examples, that part is still right. But just look at the mistake that they've made in the calculation. So, or in the formula. So it might be even, I have that open. So let's just see if they do that with a lot of, I'm just worried they do it with too many of, okay, so that was fine, that's fine. So yeah, so it seems like the one that I spotted was the only one that was incorrect. Okay, so it might be that the rest is actually fine in how they calculate it. It looks like it. Okay. Okay, but this seldom in the exam, but very likely in your assignment. Okay, but if they want to give you the T-stat to, or the test statistic to work out, they will give you both tables. They will not give you just that, so that you need to make 4 calculations to set up this table. Even if you have Excel, that is not, that they will not do. Okay. So let's finish this chapter. If we go over a few minutes, it's fine, because that is in any case just an answer set as well. Okay. So anything on dependence, independence, expected value, observed, degrees, critical value? Okay. So unfortunately, no luck there. Okay, degrees of freedom. How many ages are there? 1, 2, 3. How many Far side is 1, 2, 3. So 3 minus 1 times 3 1 is minus 1 is 4. So the degrees of freedom is 4. Correct. We're looking for incorrect, so unfortunately not. Okay, but we've done the second one. Okay, let's do observed first because observed is as is in table. The observed frequency of bias under the age of 30, under the age of 30, and bought a large car. Large car. Okay, so we basically want that number 34, 34, correct. Okay, I'm gonna keep that one not for now. I first want to check the critical value because that we can get from the table. So degrees of freedom is 4. The alpha is 0.05. So let's do critical value. Critical value from the table, we said degrees of freedom is 4. We said it's 0.5, 9.488. 9.488. Correct. Okay, so, oh man, I was hoping for an easy way out of this one. Okay, then before we do that, is T-stat bigger than critical value, we reject the null hypothesis. Okay, suppose that the T-stat is 18.35. We know the critical value is 9.488. Okay, so that's bigger than that. We reject H0. H cannot be rejected, so that is the wrong one. Okay, because we said it should be rejected. Okay, lastly, let's work this out. Expected the row of a 1 or the row column, the total of a row times the column total divided by the total will give you that. So expected frequency of bias above 45, above 45, so that's 120. Bought a medium car, so that is the total is 99, and we divide by 300. Okay, and that answer is 120 times 99 divided by 300 is 39.6. 39.6, spot on. Okay, correct. I think here is all the things how it was calculated as well for you, but yeah, so that's basically chapter what is it, chapter 10 on chi-square. So the most, for me, nearly is this slide. And then I'll, like you've seen now here in the last one, I look for the easiest nearly things that I can pick before I can need to go into depth into some of the calculations. Questions on this?
Hi, Jean.
Yes.
Just a quick general question, especially on the last example that you showed us.
Yes.
That actually, if the correct answer is number 5, that's actually going to take us the most time to find the correct one. So we work out 1, it's correct. Then we work out 2, it's correct. 3 is correct. 4 is correct. Only when you come to 5, then you realize that's the incorrect answer. Do they normally give us those kind of questions where number 5 is the correct one? Because that's going to take up a lot of time. Okay.
No, because what's happening with the online, see, when it was paper-based, that happened a lot. Online, there's 3 or 4 papers as well. So they scramble the options so that you can't chat to somebody else and say, hey, question 1 is option 3, but your option 3 is 39.6, and your partner's option is actually option 1 is 39.6. So with an online, it is one of those, it's randomized. So that's why I nearly like this process to follow, because you eliminate the easiest ones first, or hopefully you get that one of the easiest ones is what you're looking for. Yeah, unfortunately with the online, it totally threw out normal processes, how one would work, or how one would eliminate certain things.
Okay, thanks. But there's 100% that checklist or that process, the steps that you got on the top right, that's a very good guide for us to use, especially to knock out the easy ones. Okay, thank you very much.
Yeah,
Thanks.
cool. Over King, there's a question from you. Or not? Sorry, Over King, I can't hear anything. Just stopping the recording so far.